Hello and welcome to the Site Safety Index, the awareness of safety culture. My name is Ted Stewart. I am the Program Development and Compliance Manager here at Exeter. I wear a lot of different hats. I help the OEM Product Certification Group. I assist in the end user business, manage the CFSC program, and I'm also the Deputy Quality Manager that helps deal with the ANSI accreditation and all types of certifications. My background is I came from Lockheed Martin and Harris Corporation prior to working for Exeter, where I did a lot of manufacturing and lean process improvement. Always we like to do 2 or 3 slides about Exeter since there's always new people in every single webinar we have. You can see here there's a little red dot probably somewhere next to you in the world. We're growing rapidly, and it's a lot of fun to see the success that we're having with this company. Exeter is involved with the complete supply chain of functional safety in multiple different industry sectors, anywhere from the original equipment manufacturers who require product certification to that end user that actually uses the products. Now, Exeter provides the software tools, the training, the consulting, and procedures related to functional safety, security, and reliability. And you'll see here we have different products and a suite of services that we do offer. You can see all the way from the left-hand side, the consulting side, whether that's in cybersecurity, end user, ISO 26262, which is automotive and alarm management, to any type of tool you could think of that would help you make your job or your life easier. Anything, any kind of maintenance or manual calculation, we have a program that will help you. The most favorite is, of course, Excellentia. However, we have CyberFacts and a suite of other things. Product certification, we do cybersecurity certifications, we'll do functional safety certifications, even certifications in 61511, and we're also branching out to different standards like API 580, ABSME, so many new opportunities out there. Training, we do have probably a training somewhere in the world at least once a week. We stay very busy with training because that's what we're all about. Functional safety is a niche group, and there's a lot of people that are just now getting into this industry trying to figure out, well, what is this SIL thing, or what do I have to do to become safer or get a more robust system? So with that being said, that's why we also have probably the most reference material out there within functional safety, cybersecurity, and alarm management. Anything that we can think of we'll put into a book. And why is that? A couple of different reasons. The first reason is because we don't want to hold any kind of secrets. We don't want people to not be safe because they can't have access to it. So we publish everything we know. And then the second thing is, per our accreditation, one of the things they tell you is, look, if it's not public knowledge, you're not allowed to help them or tell them where things are. That's fine. So what do? We publish all of our material so that it's public information, and we're allowed to use that information not to make functional safety any harder than it already is, but to help build guidelines to guide people in the right direction. Also, the CFSC program, all of you that would like to be mentors or leaders in the functional safety world, please apply to be a CFSC, because we need more leaders. We need more experienced people to help lead and to bring awareness to safety. Now, before we get started here, I want you guys to notice that there is a toolbar on your right-hand side that you can ask questions. Feel free to ask questions all throughout the presentation, and at the very end, I will answer all of your questions. So thank you so very much. So today, measuring a site safety culture. Now, we've done a few webinars before about the Site Safety Index. I think I personally have done 2 previously, and we're also thinking about doing a part 2 because there's so much information we want to tell everybody, and this is kind of like the missing piece that goes beyond the SIL certification. Now, a number of field failure studies have shown that failure rates of identical modules in the same industry indicate that there's difference in failure rates, right? So maybe, you know, and first though, think about the terminology that we're using here with the Site Safety Index as opposed to the Company Safety Index. It is well documented that a safety protocol may exhibit a safety performance less than that specified by that manufacturer or by the FMEDA. And that even within the same company, failure rate estimates derived from field failure data can vary significantly from site to site. And I know I touched on it, but studies have shown that the failure rates estimated from the field failure data for identical modules in the same industrial application exhibit a difference in estimated failure rates from the same, or basically for the same product from site to site. Now, when compared to the inherent predicted failure rates for the same product, the FFD estimates are approximately 1.2 to 3 times higher depending on the product type. Okay, so depending if you have a valve, an actuator, a logic solver. Now, site audits have contributed or attributed these differences to the dissimilarities in the end user activities and practices which vary from site to site. Now, while if you have a company that has these worldwide procedures and policies to impact and to make sure there's consistency with safety, there's always that human factor, right? And so that human factor plays a part in safety system performance. 3 quick, easy examples is your imperfect repair, improper calibration, or faulty installation. Things happen. There's no rhyme or reason, but usually there's systematic reasons, and the operator could be one of them. Now, these and many others all contribute to the decreases in functional safety performance. Now, the Site Safety Index, it's a model, it's a simple approach, and it's based off of concepts from IC 61508 to more accurately account for site-specific operational practices. All right, let's talk a little bit more about this, because it's used to adjust the safety metrics computed under the assumptions that human factors play no part in safety system performance to reflect the effects of human factors on the safety system performance on a site-by-site basis. Okay, now this approach, which is great, is that it allows those companies that are doing the right thing, that are following their procedures, that are doing their approved tests on time, you know, and not waiting for a material to go end of life before they replace it. They're doing all these things. It now allows them to gain credit so that they can actually reduce their failure rates compared to somebody else next to them because they're doing all the right things, all right? And it's not going to mask issues from another site. So even different sites can have different failure rates, and we're finding that out more and more. Okay, so you want to know about this evaluation. Well, there's 2 different ways that SSI can be evaluated. One is via an external audit. What this does, it provides the most accurate measure of SSI. Okay, and then the next thing is a self-administered questionnaire, which relies on less information than the audit and provides an approximate measure of SSI. Okay, so let's talk quickly about the first one, the external audit, right? So what happens is the professional comes in and evaluates your site. Okay, now the International Standard of IC 61511, they list the requirements that must be met for the entire safety lifecycle process. Okay, so in an on-site audit, it can be verified that the site meets these requirements in combination with additional details and requisites for the operations and maintenance activities. Additionally, all safety and lifecycle procedures are audited to be sure of a few different things. Okay, the first thing is that all the procedures are adequate and they support the requirements. And also another thing that they do is that they're being correctly followed at that site. The outcome of the audit is a report. It includes an SSI score obtained and as well as recommendations for changes of improvement. I think that's the most important thing with this site. Sure, they come on site, they'll look at everything, but just getting that report showing how you can improve is awesome. Because, I mean, if you go to work every single day, you miss the things because you're blind to them because you're used to seeing it. However, if you could have a third party come in, a different set of eyes, and say, hey, look, actually, if you're doing it this way, you could actually reduce your failure rate, you could improve this process, you can make it more consistent, and you'll start understanding the impacts of what you're doing, if it's right or if it's wrong. Okay, so let's go to number 2. Via a self-administered questionnaire. A site that is interested in acquiring an approximate measure, okay, just an approximate, of its own state of safety culture may actually choose to complete a questionnaire. It's roughly about 40 questions, and this represents a subset of the information gathered in a complete audit. These questions will cover activities and practices spanning a big portion of the life cycle. This can be installation and commissioning, safety validation, operations and maintenance, SIF modification, and also, of course, decommissioning. All right, so here are a few sample questions. Like I said, if you did the questionnaire on your own, there's good 40 questions or so that touch a broad range of the life cycle. These questions here specifically are for the operations and maintenance phase of the life cycle. And we can make the complete set of questions available. If you want to just contact me, I'll put my email address at the end of this presentation. If you're curious into seeing these additional questions. Now, how you answer these questions, it's real simple. It's you either say always, you can say often, you can say never, or you can say not applicable. And of course, as you answer these things, they're all weighted. Okay, so it's a weighted score, and the total score received determines an approximate SSI level for that site. The basis of this validity of using the questionnaire for determining SSI, it's actually an accepted practice per the standard, per IEC 61508. And using a questionnaire to determine the beta factor that describes the extent of common cause failure to be modeled when you're actually evaluating the safety performance of a redundant SIF architecture. And as you can see, I know you guys have probably already started reading these questions, but I mean, they're good questions because if you go halfway down, you see when this says, do you perform periodical proof tests using written procedure? Your probably quick answer to that is, of course I do. However, think about it. Do you think who you have in charge of working on the proof test, do they do it by memory because they're so used to doing it? Do they have the procedure in their hands? Is it hard to locate? Do they do it on time? And these are things you start thinking about, well, maybe I don't do it all the time, or maybe I do skip this one step because I don't see any reason in doing that for the proof test. So you'll start seeing more and more, and it's almost eye-opening in a good way. All right, so now that I've talked to you about the different ways to have an SSI, you can do it in-house, out-of-house, you can do a questionnaire. You have some questions here, but let's look at the different levels for the Site Safety Index model. You have 5 levels, okay, 0 to 4, and the SSI number is an indication of the level of site activities and practices that can contribute to the safety performance of SIFs on that site, okay? Now this table, it details the interpretation of the SSI level, and note that it does mirror the levels of SIL assignments, okay? And that the SSI 4 implies that all requirements of IEC 61508 and IEC 61511 are met at the site, and therefore there is no degradation in safety performance due to the end user activities or practices. So what am I saying here is, so again, example, if you're an SSI 4, what does that mean? That means you have no room for error, right? Basically, you are not human. It just means you're perfect. You don't do anything wrong. You're the golden child. You walk on water. I mean, it's just like absolutely perfection, which isn't likely. And that's okay because there's a lot of products out there that you don't need perfection. That product is not that technical. You're not working at a nuclear plant, or you're not working somewhere where it's extremely critical, because what we typically find is SSI 2. That's normally where people are, which is good. Well, I guess good would be SSI 1. So if you're typical, what does that mean? It means that repairs are mostly correct. You correctly get them performed. Testing is mostly done correct and on schedule. Sure, if it's a day here or there, it's okay. You're just working on a repair. Most equipment is replaced before the end of useful life. You know, you don't wait till that last day to change that piece of equipment. And if you do, it's not a big deal. So you can see it's more of a, I'm doing a good job, I'm not doing a great job. That's normally where we see people at, and that's fine. It's completely okay, because where that product is being used, they don't have to be that strict. Now, we have done assessments where people are SSI 0, and you know what? To them, it's okay. Now, I don't know why they'd have us come in to learn that, because there's no process in place. However, there are facilities that it's acceptable to be SSI 0 because of what they are making. And of course, there are some that we have that are SSI 3. We've never seen an SSI 4. Why? Because people are human, and that site isn't 100% automated. But SSI 3, we have a few of these people, which is fantastic. We want more, because what does that mean? That means that this equipment that you're putting in your SIFs is being put to good use, right? So if you have the best equipment in the world, how good is it if you don't treat it right? If you're not following your own procedures, or you're not doing those proof tests, all of a sudden you can have the most expensive system in the world, or spend all this money on these SIL certified products, but if you're not going to use them right, you defeat the entire purpose. All right, so let's talk about the impact between different site safety index models, okay? The specific ways in which SSI modifies the key variables, for example, it could be the device failure rates, the proof test effectiveness. These all impact that PFD average. It'll impact the SIL level, the rating, impact the risk reduction factor, as well as other safety metrics. Later on the slides, I'll kind of go into a little more detail and share a little more examples, but now let's just look at this hypothetical example. All right, this example is going to show how an SSI rating can be affected and can actually change a system's SIL capability depending on how well you're performing. All right, and now in the figure, the computations were actually performed under the assumption that this is an SSI 4. Okay, these are perfect people, and thus the end user activities and practices do not degrade the safety performances of the SIF. Now note that in this case, the SIF SIL level is right here. Okay, SIL 2, and it's based on the PFD average, that first circle you see in red. Okay, and then also notice the risk reduction factor is 113, which is above that 100 mark. It's slightly greater than the requirement of this opening hypothetical example. What happens now if we compute and we go to an SSI 3, which is still great, but remember, at SSI 4, it just barely hit the SIL 2. Well, I don't think I would have had to tell you, but of course, in this figure, the analysis is repeated, but because it's now an SSI 3, and based on the PFD average, the SIL performance is now a SIL 1. And the risk reduction factor is now under that 100 marker. It's at 98, and this is insufficient for the requirements of the example to hit SIL 2. So this shows how the impacts of safety activities and practices can be quantified, and how effects of changes in these activities and practices can be measured. And I think that's very important because this was all used to be by word of mouth or by a thought process. Yeah, you know what, if we don't do this well, I think it will hurt us and the failure rates will increase. Well, now we have something not qualitative but quantitative as well to help us make these judgments. The SSI provides a simple means to measure how well that site-specific end user activities and those practices support the achievement and retention of the SIF to its maximum safety performance. Further, they can be used to adjust the metric of SIL safety performance from the ideal achievable to a more realistic measure of what is actually attained at the specific site, given the site's activities and practices. All right, so a key metric for the process industry for this designs is called, like I said, the PFD average. Now, after several studies of field failures and proof test reports, we have identified several variables as the key to a realistic PFD average calculation. I threw in a white paper that we did a little bit ago. I have two others actually that helped me create today's webinar, and at the very end of this presentation, I'll include the locations of those white papers so that you can go and download them for free, and you can just keep a copy of them on your desk or wherever you need to put them. Okay, so now let's talk about these 9 variables. A key metric for measuring the safety performance of SIFs is the average probability of failure on demand, right? That PFD average. And now, if other closely related metrics are risk reduction factors. You have the safety integrity level, and you have the mean time to fail safe. And based on studies of the field failure data and proof test reports, these 9 variables impact the PFD average. Okay, the first one is the failure rates of each product, including failure modes and diagnostic coverage from the automatic diagnostics. Many of you have know that one. You have the mission time. You have the proof test intervals, proof test effectiveness, proof test duration, mean time to restore, the probability of initial failure, the site safety index is what we're really talking about today, and of course the redundancy of devices, including that common cause failure. Right? All right, so now of these key variables, how many are impacted by that specific site? All right, let's take a look at it. Well, clearly redundancy of devices, if you have that redundancy, it's not an attribute of an end user practice or activities. The SSI itself is not modified in safety performance calculations, and rather it's actually used to modify many of the other variables which impact the PFD average and other metrics. Now, specifically, whenever SSI is less than a 4, there are 5 key variables of the 9 that are that become modified. All right, so you have the failure rates of each device. You have the proof test intervals. You have the proof test effectiveness. You have the mean time to restore, and of course the PIF, or the probability of initial failure. These are the 5 that become affected by that PFD, or that affect that PFD average. And the Site Safety Index, now this actually models the accounts for which the differences between targets used during a conventional calculation and the reality of a site due to the impact of operational processes, right? Because you might get this FMEDA and say, and not know, or that maybe your certificate has these failure rates on them, and that third party didn't disclose what your SSI rating was. Maybe they gave you these failure rates. They look fantastic on paper. Why? Because they gave you failure rates for an SSI 4. And you know willingly, I'm not an SSI 4. Not sure marketing loves that. They can sell the heck out of that product. But is that reality? So what are we trying to pitch here? So now why is it important? Well, the key variables in a PFD calculation are impacted by site operational practices, and we now know that. And a model can now show this impact, and it can be used to show the benefit of an improved operational process. So finally now you have this quantitative analysis that can share the life cycle cost comparisons to justify improving your operational processes, right? So now you have a way to speak to management or whoever you need to say, hey, look, here's where we are, here's where we need to be, and here's a quantitative way of showing how we can improve. All right, so now let's talk about a little bit more here. There's several factors that have been identified thus far which impact this SSI, okay? And these are your commission test, your safety validation test, your proof test procedures, the documentation, fair diagnostics and repair procedures. You have your device of useful life tracking and replacement process. You have your SIS modification procedures. You have your SIS decommissioning procedures. And yeah, there are many others. And this is when that questionnaire comes into play. So now how are the key variables impacted by these site practices? All right, and so that's what we want to do is, those 5 that we just spoke about, I'm going to show you just kind of quick examples of each one that outline what happens and how are they impacted. Well, the first one is your fail rates of the product. How are these impacted? Well, you have the FMEDA failure rate predictions. When a FMEDA is done by a third party, these products are under the assumption that they're installed in an environment that has been verified according to the manufacturer's specifications. You have the products are chosen with materials capable with any process chemicals. The products are commissioned and calibrated according to the manufacturer's instructions. Okay, these are all assumptions. And and in a lower SSI level, these activities may not be done well. Which, what does it do? It increases the probability of failure. And now that FMEDA that you have, or that certificate of these failure rates, it's not accurate. It's actually, those failure rates are going to be a lot higher because of that. And from the studies that we've done on the billions of unit operating hours that we have, it actually indicates a failure rate multiplication factor between 1.2 and a 2. Let's move on here. What about the actual proof test intervals? Well, in site surveys done by Exeter, it is apparent that proof tests were postponed in sites where a high level of operational discipline was not present. Makes sense, right? So if the priority isn't there, or if they're too busy, of course those proof tests are going to be postponed. The discipline's not there. Maybe they're not trained to know why it's important. And when this happens, those actual proof test intervals are increased in a lower SSI level. All right, the next thing I think is, the effectiveness, okay? So now you're going to start seeing a common trend in basically people's schedule, timeline, and importance, and knowing if it's well documented or not, because your proof test effectiveness, it will actually decrease. It won't become as effective when procedures are not clear and when test personnel do not have sufficient time to perform and document that testing. And this is something that I've learned, and a lot of these I've learned without knowing about functional safety prior to working at Exeter, is that management puts such pressures on you to hit numbers, to meet goals every single day. So if it's almost physically impossible to meet that goal, what do you have to do? Well, you have to find a way, well, what if I did this way? What if I just did this? I can get this many more made, or I could do this many more for this number of widgets. And all of a sudden now, if you have to do a proof test on top of that, guess what? You might not do it effectively. It's going to decrease, and that's going to hurt you in the long run, because that's going to drive your failure rates. All right, let's move on. Once again, that mean time to restore. Well, once again, it's going to increase if that diagnostic procedures are not documented well. Or what if they're not even understood? Or what if they don't know where the documents are even located? Well, your mean time to restore is definitely going to increase when proper tools are not available for those items to be fixed, those widgets, and some restore efforts will not be successful when those personnel don't have the time and they don't have the documents, and actually a second effort is needed to complete it. Maybe management comes down and says, look, I got to get this done, and they do it, or that supervisor. So the actual MTTR is increased in a lower SSI level. All right, so now let's talk about probability of initial failure. Products used in a safety instrumented function may not operate properly if they have not been installed, calibrated, and tested during the commissioning process. That makes sense, and it's so interesting how many times things can get overlooked. Maybe that guy's been here forever, and he's just like, yep, let me install it real quick. Doesn't look at anything, just installs it, and he may or may not even complete the commissioning process. Or maybe these procedures that we think are so clear are actually not clear, and and once again, what if there's no time available? The probability of initial failure will actually increase, and this probability of initial failure is increased in those lower SSI levels, which is not uncommon. All right, so I kind of wanted to touch briefly on all those different areas. Wanted to give you guys some examples, and this is kind of a quick summary slide on, so what will the Site Safety Index model do? Well, it's going to provide more realistic PFD average results. All right, it's going to be compared to simply adjusting your failure rates. This will actually allow a site with a strong safety process to take credit for that accomplishment while not masking those other issues at the other sites. So sure, you might have a site in a different location that has the same procedures, they just don't get it though, or they don't have the right people. Well, don't let those failure rates hurt at this site, right? Site A, so you can say, okay, this site is an SSI 3, here's an SSI 1, and you can know what the failure rates are going to be for the different sites, at least have a better understanding, and you don't have to take worst case, which is what usually sometimes happens. And these great locations are now hurt and now are masked because of a different location. And it can show the impact of different operational policies that can be used to show the benefit of an improved operational process. And I love the fact that you now have a quantitative way to justify approved operational processes. Like I said, there will probably next week a similar topic going more into detail in the Site Safety Index that is not yet confirmed. However, for today's webinar, that's the information I want to give you. This is the information that we keep getting questions about. I hope I got everybody's questions. I was monitoring them as I went through. Here are the 3 white papers that helped me today build this webinar. I fully recommend at least just downloading them. Get yourself a copy of them, put them on your hard drive, and look at them whenever you can. Print them out, put them next to you, and keep it in mind because it's very interesting. And if you do want to get a list of those questions, send me a quick email. I'll make sure I get that over to you. Get your address to the right person who has the information. And let's see if I can answer some more questions here. Let me pull a few up. All right, so the first question I have here is, how is SSI different to beta factor? Well, the quickest thing or the easiest thing to know is your beta factor is actually just for your common cause. Okay, so just keep that in mind. Beta factor is only for common cause. SSI is not. All right, and next question I have here is verifying the SSI part of the new IEC 61511 requirement. Actually, great question. Now, SSI, it's a way to more accurately model the existing requirements. SSI specifically is not a requirement for IEC 61511. Okay, we recommend it, but it's not mandatory, and you do not need to be measured by it. However, hopefully today you saw why it would be nice so that you can more accurately predict your failure rates for site to site. How often should SSI evaluations be performed? Well, since there is currently no requirement for this evaluation, it's really up to that organization. What we've seen here at Exeter is that many companies will hire us to see where they are, right, to benchmark it. They'll take away the report, and then they'll come back and say, hey, Exeter, would you come back out again, reevaluate us, and see how we've improved over the period of time. That's always a lot of fun to do. It's great seeing people improve and change procedures to make themselves a safer company. So we really, really enjoy that one. All right, let's see here. This is more of a comment. They said, I believe that not only will it justify better operational processes, it will also improve the maintenance program. Yeah, thanks very much for that comment. That SSI was created due to end user requests, so we're glad to see that you actually value this evaluation. So thank you very much. Any other questions? That looks like that is it. Everybody, thank you so very much for your time today. We always appreciate everyone taking these moments with us. So until next week, thank you so very much. I really appreciate everybody. Have a great day, good night, good evening. Take care. Bye-bye for now.